magnetic scissors.
Here's where the physics gets fascinating. A CME doesn't just blast through space. It carries with it a tangled web of magnetic field lines from the sun. A comet's ion tail is also governed by magnetism. The charged particles of the tail are essentially clinging to invisible magnetic tethers that stretch for millions of kilometers. The real drama happens when the CME's magnetic field collides with the comet's magnetic environment. If the magnetic field embedded in the CME has an orientation that is opposite to the comet's field, a southward BZ component in space weather terms, it can trigger a process called magnetic reconnection, a concept first theorized by physicist Hannes Alf Venn. Think of it like a cosmic short circuit. The magnetic field lines from the CME and the comet's tail can snap and violently reconfigure, releasing a tremendous amount of energy and accelerating particles in the process. In practical terms, this process can act like a pair of magnetic scissors, literally severing the comet's ion tail. This causes a whole section to break off and drift into space, while a new one begins to form almost immediately behind it. This spectacular phenomenon is known as a disconnection event.